I'll give you for the first 5 minutes. I'm going to give you some overview. Okay, I'm just going to give you some overview about what. I'm just going to give you an overview of what exactly the subject is all about, and then maybe we can take up different topics. Okay, right. So sorry for the glitch which happened yesterday. Okay, usually it doesn't happen, but otherwise the class would have happened. Okay, but don't worry. We will make sure that you understand the concepts and you're able to solve the problems in the examination. Okay, right? So we'll help you out. Not to worry. Okay, I've got lots of messages, right? And don't worry. Okay, we'll definitely help you out. Okay. What is this operation research? I hope that you have studied basic quantitative techniques. Apart from that, this operation research is also another subject which is going to help you help managers take decisions. Okay, right? So you don't have to see any book. Okay, I'm not going to see any book or anything. Okay, just listen to the class. Okay. Uh, can you all see my screen? Can you all see my screen? I hope you all can see my screen. Can you tell me in the chat box? Can you all Can you all see my screen? Okay, excellent. Good. Okay, so I'm not going to read out from the book. Okay, that's not the way how I teach. Okay, I'm going to give you concepts. Maybe if you want, you can record it. Okay, and you can play it. Otherwise, you just let me know some few topics which you need. Okay, I will. I have a YouTube channel. I will post it on that. Okay, right. So, what is this operation research? It's very simple. See, operation research is basically like an extension. Okay, it is going to help managers. It is going to help managers take decision. Okay, so how operation research is going to help managers take decision? It is like uh, there are different techniques. Okay, there are different techniques, methods which is used. Okay, for taking decisions. For taking decisions. Okay, and we are going to learn all these. We are going to learn all these techniques. Okay, we are going to learn all these techniques in operation research. Okay, right. So we will see all these techniques. Now, with respect to the exam point of view, I will tell you which is important and which is not important. Okay, see, if you look at the 20-mark question, okay, usually what are all the problems which is coming in the 20-mark question is one simplex method. Okay, this is the favorite question for examiners. Okay, so simplex method is something which comes for 20 marks, and of late, if you see the last 4 or 5 year papers, there have been questions on PERT CPM, okay, critical path method and project evaluation review technique, okay. And apart from that, there have also been problems on replacement. There's been problems on replacement, okay, or maybe sequencing 4 machines or 5 machines, okay. But the most favorite is the most favorite topic for the 20-mark question is your simplex method. Okay, so usually people are going to choose simplex or PERT or CPM or whatever it is. Okay, right. So it's very important that you touch upon this. And if you look at the 10-mark question, you will definitely get it on graphical method, you will get it on game theory, you will get it on maybe sequencing 2 machines, or you may get it in this one, what is that, transportation or assignment. Okay, so these are all your 10-mark question. Okay, and rest assured, don't just go study theory and go to the examination hall, you'll definitely flunk. Okay, you'll fail. Okay, so this is a problematic paper. Make sure that you try to learn all the problems and techniques before you go. So like yesterday I was telling, no, it's a 80-20 probable paper. Okay, so 80% will be your problems, and 20% you can expect theory in the 5 mark question. Okay, so usually it will be of 5 marks, 10 marks, and 15 marks. Okay, so that's exactly how it is. Okay, uh, that's exactly how things work in applied operation research. Okay, right? Don't raise your hands, guys. Lower your hands. All your doubts will be cleared. Okay, when I'm teaching, don't raise your hands. All Priyadarshini, Harini, Vijay Bharti, all lower your hands. Don't worry. All your doubts will be taken later. Okay, right? So what I'm trying to say here is, let us go ahead and learn all the techniques. Okay, we'll learn all the techniques in operation research. Okay, right? So what's gonna happen here? Just give me one moment, guys. Okay, right. So what I was trying to say here is, we will go ahead and see all the different techniques. Okay, which is there in this particular subject. Okay. So, how do you want me to start? You want me to start the 20-mark question, or you want me to start the 10-mark question, or how do you want to start? Maybe you can use the chat box and tell me. How do you want to start? How do you want me to start? Do you want me to start the 20 marks? Okay, 20 marks. Okay, okay. Okay, great. Okay, fine, no problem. No problem. So we can go ahead and see. We can go ahead and see the 20-mark question. Okay. 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 Right. Good. Good. Okay. 20 marks. Start with 20 marks. Okay. Good. So I'll teach you the 20-mark question, um which is your simplex method. Okay. Right. The simplex method is going to come in linear programming problem. Okay. Right. So what is this linear programming problem? How you have to identify this particular problem is very, very important. Okay. See, in linear programming problem, there are three types. Okay, three types of problems which is listed out. Okay, one is your graphical method. Okay, that is one thing. Another one is your simplex method. Another one is two-phase simplex method, and another one is your big M method. Okay, right? So don't go ahead and break your head on two-phase and big M method. Okay, usually they do not ask these two techniques. What usually comes in the examination is your graphical method for 10 marks and simplex method for 20 marks. Okay, right? So what is this linear programming problem, and how you have to solve this particular uh, problem is what I'm going to tell you now. Okay, so pay attention. Okay, so I'm going to lock the meeting. Okay, no further disturbances. Okay, so people who have joined, people who have waited for my class, thank you very much. I understand the effort and time. Okay, right? And those who have not joined, absolutely no problem. I'm not going to uh, debate on it. Okay, right? So the meeting has been locked. Uh, tell others to join some other link. Okay, okay. So this is just to make sure that we are not getting disturbed. Okay. So what is this? What is this simplex method? Okay, and what is this linear programming problem? I'm going to tell you about this. Okay, see, linear programming problem. What do you mean by linear? Linear means it is raised to degree 1. Okay, so any equation which is raised to uh, degree 1 is linear. What do you mean by that? So x plus y equal to 7. This is a linear equation. Okay. If you have x square plus something, x square plus 7x or 7y is equal to 9. Okay, so this is a quadratic equation because it is raised to the power 2. Okay, it is raised to the power 2. Are you getting my point? Okay, so we are going to see only equations which is raised to the power 1, which means to say x plus y equal to 7 or 2x plus 3y equal to 9. Okay, so it can be anything, right? So this is what is linear equation. So the power of the equation will always be 1. Okay, now, your linear programming problem will have three parts. Okay, your linear programming problem will have three parts. Okay, first one is called as your objective function. Okay, first one is called as your objective function. Second one is called as the set of constraints, and third one is called as your non-negative restriction. Okay, so you can come to know that in any linear programming problem you have three parts. One is your objective function, set of constraints, and non-negative restriction. Okay. What is this objective function? Objective function is something which has maximization or minimization. So if you open your book and see, there'll be something called as maximize or minimize. Okay, so whenever you have this word, okay, it is going to tell you that that is the objective function. Okay, what is this maximize and minimize? You need to understand. Okay, what is maximize? Maximize means I'm going to maximize my profits. Okay, profits should always be maximized. Then what should be minimized? Minimized means the losses. The losses has to be minimized. Okay, so I'm going to minimize the losses. Okay, right. So either you maximize the profit or you minimize the losses. Okay, that's the meaning of it. Either ways, you are going to get profits. Are you getting my point? See, I mean to say that you have a product. Okay, so you have a product. Let me say you have a product. Okay, you have a product. If you are going to maximize your profit, how? Let me say I'm going to cut down my expenses. I'm going to cut down my transportation cost and all those things. So you can set a higher margin. You can set a higher margin and then you can earn profits. That's exactly what I'm trying to say. Okay, right? So as a company, you should always try to maximize your uh, profits. Are you getting my point? So that's how it is. Okay, right. So that's what is maximization. Maximization means you're going to maximize the profits or you're going to minimize the losses. Okay. Apart from that, you have something called a set of constraints. What is set of constraints? Set of constraints means whenever set of constraints means whenever you people, okay, are manufacturing something, okay, there might be so many obstacles or hurdles. Okay, there might be so many obstacles or hurdles. Okay, you do any business, there's going to be so much of hurdles, okay, problems which is going to stop you from attaining your objective. Okay, so when you people are not able to attain your objective and something is stopping you, that is called as set of constraints. Okay, that is called as set of constraints. Okay, so either your set of constraints can be two equations, three equations. Okay, it depends. Okay, so in your examination you may get two equations, three equations, don't bother. Okay, right. uh, yeah, but rest assured it will not go beyond three equations. Okay, so for that, you are going to use an identity matrix, which I'm going to tell you in a short time. Okay, so that is about set of constraints. Then you have the non-negative restriction. What is non-negative restrictions? These are the restrictions which do not take a negative sign. Okay, the least value which it can take is a 0. Are you understood? Okay, right. So 0 is the least value it can take. 0 and above 0. Okay. In your linear programming problem, I'm going to say 0 as a positive. Okay, right? Make sure that you know this point. Okay. 0 is taken as positive. Okay, something which is going less than 0, that is -1, -2, -3. These are all negative. Okay, but in simplex method, it's usually 0 is considered to be positive in linear programming problem. Okay, very important. Okay. So what did I talk till now? It's very simple. I spoke about three things. Okay, your simplex method is going to have three parts: objective function, set of constraints, non-negative restrictions. These are the three. Parts of any linear programming problem. Okay, right? So you should identify these three things. Okay. Right. So apart from that, what I'm going to tell you is the process of simplex method. Okay. See, always remember that you should know the formulas. You should know the steps. Okay. So I hope that you have studied, you have written quantitative techniques. So you should know. Okay. Right. So what I'm trying to say here is, um, what are the methods? I mean, what are the steps which is there for your simplex method? Okay, if you want, you can record this. Okay, what are the steps? First, your simplex method has to be identified. So how do you identify simplex method? This is the most important thing. Okay, many people in the examination, they do not know how to identify simplex method. Okay, they don't know whether it is simplex or two-phase or big M. They do not know how to even identify the problem. Okay, which is a very sad thing. Okay, so how do you identify the problem? It's very simple. See, uh, whenever we are dealing with simplex, okay, the objective function should always be set to maximize. Okay, the objective function will always be maximize. Okay, and the set of constraints will always be less than or equal to. Okay, and the non-negative restriction should be greater than or equal to 0. Understand this. This is very important. Okay, right? In simplex method, the objective function should be maximization. Are you getting my point? Set of constraints should be less than or equal to 0, and non-negative restriction should be greater than or equal to 0. I'll tell you. I'll tell you how this works. Okay, I'll show you. I hope you can see my screen. I'll show you. I hope you can see my screen. I hope you can see my screen. Can you show sample some? I'll show you, man. Wait. Have some patience. Vigneshwaran, I'll show you. But first, now you tell me whether the screen is visible. So many messages. These people are wanting to join. Okay, right. So I hope you can see my screen. In my screen, I will show you. Right. You see here. I just take one image. Can you see this? Can you see this? I have just typed simplex method. Okay, I just want this. I just want this. You just focus on this. I'll put it. I'll put it on the chat box. Okay, right. So I have shared it on the chat box. What did I say? I gave you a very simple thing. Okay. So what did I tell you? Uh, okay, right. So what did I tell you? The way how you have to identify the simplex method is very simple. Okay. So first thing is your objective function should be maximized. The second thing, the set of constraints should be less than or equal to, and your non-negative restriction should be greater than or equal to 0. Now you see here, maximize. Okay. Maximize. So this is your objective function. Either you will get a P or you will get it as a Z. Z. Okay, or they use two things. Either you can get profits, maximize P is profits, or you get maximize Z equal to something. Okay, that's the first part. The second part is subject to, subject to. So here you see here less than or equal to, less than or equal to, less than or equal to. So this means that your non-negative restrictions is less than or equal to 0. Then sorry, set of constraints is less than or equal to. Then your non-negative restrictions will be greater than or equal to 0. These are the three parts. These are the three parts. I hope uh, you people can identify the three parts in the linear programming problem. Are you getting my point? Okay, right. Okay, good. So did you all are you all able to identify the three parts? Can I uh, get a yes in the chat box? Very good. Okay, right. So you are able to identify the three parts in the simplex method or your linear programming problem. Okay, can you explain again? Okay, it's very simple. See, இல்ல ஒண்ணுமே இல்ல. There are three parts. மூணு part இருக்குமா? Maximize P equal to 0. So this is maximize. So simplex method எப்படி கண்டுபிடிக்கிறீங்கன்னா, whenever you have maximize, then you clearly say that it's a simplex method. Okay, right. Then subject to. You see here, it is less than or equal to, less than or equal to, and less than or equal to. See the cursor. Less than equal to, less than equal to, less than or equal to. So your objective function should be maximize, your set of constraints should be less than or equal to, and your your non-negative restrictions should be greater than or equal to 0. அவ்வளவுதான். So in the மூணு condition satisfy ஆச்சுன்னா definitely you can say that this is a typical example of simplex method. You can solve the problem by using simplex method. Okay. But however, there are certain exceptions. Okay, I have given problems in the examination wherein I have given the objective function as minimize and the set of constraints as greater than or equal to. I will tell you how you can solve that problem also. Okay, but as of now, you just learn how do you solve the standard problem. Okay, are you getting my point? Okay, let me again lock the meeting. I will admit these people. Okay. Good. Lower all hands and lock the meeting. Okay, good. Okay, fine. So, how do you solve this problem? Okay, now you know how to identify it. Okay, now how do you solve this problem? It's very simple. Okay, you have a table. You can record this also. Okay, you have a table. What is the table all about? The table has many columns. Okay, and you need to know what are all the values which is coming inside the table. Okay. So what are the components which you get inside the table? Okay. One is your CB, another one is XB, then followed by X1, X2, X3, S1, S2, S3, then solution, then minimum positive ratio. Okay, right. Apart from that, you have your other things, that is your CJ, then you have your ZJ, then you have CJ minus ZJ, which is called as the net effective change. Okay. So I'll give you the notations for all this. Okay, what is CB? CB is cost of the basis. XB is value of the basis. X1, X2, X3 is nothing but your basic variable or decision making variable. S1, S2, S3 is called as the slack variable. And then you have your solution, you have your minimum positive ratio. Okay, and Cj is the cost of the objective function. Zj is called as net change, and Cj minus Zj is called as net effective change. Okay, this is what you have to remember. This is a table. It's a table. Okay, so you have to remember CB, XB, X1, X2, X3, S1, S2, S3, solution, minimum positive ratio, CJ, and below that you have CJ minus ZJ, and then you have your ZJ. Okay, so this is the table. Okay, don't worry, just listen to the class. I'll share the notes. Okay, I'll share the notes. You can view that. Okay, as of now you just listen. Okay, right. So this is how it is. This is how the table looks. Okay, right. And maybe I can share it right away so that you can know. Okay. Okay, I don't have it here. I've not clicked that, but rest assured I will share it. Okay. Simplex table. Okay, not an issue. Okay, I will I will maybe draw it for you. Okay. Uh, Excel. So till here, I hope you all have understood. I hope you are not visible. I'm visible. Yeah, I'm visible. Check your connection. Okay. So what I'm going to do here is I will show you. Sorry. You see how it goes is it is like CB. Okay, then you have your XB, then you have your X1, X2, then X3. Okay, then you have your S1, S2, S3, then you have your solution. Okay, then you have minimum positive ratio. Okay, right? And then on top of XB, you have CJ. Then here under XB, you have S1, S2, S3. Okay. Uh, Here it will be set to 0, 0, 0, 0, 0. Okay. And then you have your Zj. You have your Zj here. And then you have your Cj minus Zj. Okay. So I'm going to tell you all this. Okay. So Cb is what? Uh, it's cost of the basis. Okay. And Xb is what? It is value of the basis. Okay. Then you have your uh, X1, X2, and X3, which is your basic variable or decision variable. Okay. And then you have your S1, uh, S2, and S3, which is called as the slack variable. Okay. Right. And see, this basic variable is certain. Okay. This is certain. Okay. And slack variable is uncertain. Okay. Uncertain. Then next you have your Zj, which is called as the net change. Then you have your Cj minus Zj, which is called as the net effective change. I get my point. Okay. Solution. Solution. Solution is nothing but the value after the inequality sign. Okay. That is the solution. Then what is minimum positive ratio? Minimum positive ratio is nothing but your solution divided by corresponding value in the key column. Okay, and then you have your uh, key element, which is nothing but the intersection of uh, key row and key column. Okay, that's the concept. Okay, right. And one more thing, you can just put a note. What is the note? We always want certain variables in the simplex table. Okay, we always want certain variables in the simplex table. What do you mean by that? X1, X2, and X3. Okay, and we got to remove. Okay, we got to remove the uh, uncertain variables. We got to remove the uncertain variables. Which are the uncertain variables? The slack variables. That's S1, S2, and S3. Okay. So what do you mean by that? We are good if X1, X2, and X3 enters the simplex table and S1, S2, and S3 leave the simplex table. Are you understanding? Are you understanding? Are you understanding? So that's the concept, guys. So this is your this is your this is your simplex table. Simplex table 1. Okay. So that's how it is. Okay. I did not put one more thing. Nobody asked for it. Your Cj. is what? Cost of the objective function. Understood? So I have given you the entire concept. So this is your concept. This is your concept. Okay. Uh, then later on, what you can do is we can add. Okay. Maybe I'll add it right away. I'll add it. Okay. So what do I want to add? I will say uh, this one. What is that? We uh, replace. We replace the uncertain variables. Uncertain variables. Okay, from the simplex table, and then uh, no, we replace the uncertain variables from the simplex table as we increase the number of iterations. As we increase the number of iterations, iterations means simplex table 1, 2, 3, 4 like that. Iterations and end end the process when all the Cj minus Zj values are 0 and less than 0. Are you getting my point? Okay, right. So what am I trying to say here? What am I trying to say here? What I'm trying to say here is, oh God. Correct. Where did that go? Yeah. Okay. Let it stay like that. Okay. So we replace the uncertain variables from the simplex table as we increase the number of iterations and end the process when all the Cj minus Zj values are 0 and less than 0. Okay. That simplex table, okay, is called the optimal simplex table. Optimal simplex table. Then we take the corresponding values of the x and y and substitute the values in the objective function and get the value of maximize z. That's all. Okay, that's all. So this is the overall concept, guys. This is the overall concept, guys. Okay, right? I hope you have understood. Okay, this is the overall concept. If you know this concept, then you are good to go. I mean to say you will be easily able to solve any problem in simplex method. Okay, right? So you need to know the table. CB, XB, X1, X2, X3 solution, minimum positive ratio, Cj. Then you have your Zj, Cj minus Zj. So this is your table. Okay, and then you need to know some basic things. Okay, CB, XB, X1, X2, X3. What does it mean? Okay, and then you have to say, okay, how do I solve the problem? Okay, so you need to know which is the key element, you need to know which is the key row, key column. Okay, maybe I can include that also. All right, so it will be complete. Okay, so that's the key element. Then you have the column key column. So what is that? The highest value in the Cj minus Zj row is the key column. Then key row. How do you find out the key row? The key row finding out is very simple. The least positive value in the minimum positive ratio. Okay. The least, sorry, my bad. The least positive value in the minimum positive ratio. Okay. Let me put it like this. The row, this makes better sense. The row that corresponds to the least positive value in the minimum positive ratio. I mean to say what I mean to say here is the minimum positive ratio is here. So let me say here it is 1.5. Another one is minus 3. Another one is 2.4. Okay. Now you see here, what does this say? Minimum positive ratio. So be very careful. Here people commit mistakes. See, first word is minimum. What is the minimum? 1.5 minus 3, 2.4. Which is the least? Least is minus 3. But what does it say next? Positive. It has to be positive. Don't take negative. Now 1, 2, 3. So you are here minus 3. This is negative. I cannot consider it. So which is the next least? The next least is this positive 1.5. So that will be your key row. So the row which is corresponding to the, that's what it says, the row that corresponds to the least positive value in the minimum positive ratio column. So that row, this row will be your, sorry, this row will be your key row. Okay, this will be your key row. Okay. Now you have your, what does it say? The key column, the highest value in the Cj minus Zj row is the key column. So till where you have to consider Cj minus Zj, you have to consider it till here. Up to S3. You can't take the solution. Are you getting my point? So I'll give a different color for this. Okay, maybe orange, right? Now you see here, let me say some random values. So uh, minus say 9, 4, minus 6, okay, minus 6, and then you have 1, 6, 2. Okay, these are all completely random. Okay, so what does he say? He says the highest value in the Cj minus Zj row. Now you see here 9, 4, minus 6, 1, 6, 2. Okay, so in this, which is the highest? The highest is this. The highest is this. So this will be your, this will be your key column. Okay, right? I'm just going to erase this. This is just for your understanding I put. So here the highest is 9. Okay, so this will be your key column. This will be your key column. Okay, now this is your key row. This is your key column. This is your intersecting element. This will be your KE. This will be your KE. Okay, KE is nothing but key element. What does it say? The intersection of key row and key column is your key element. Are you understanding? Are you understanding, guys? Okay, right? So that is the intersecting part. Okay, key row and key element. Okay, right? So the intersection of the key row and the key column, wherever it is intersecting, that will be your key element. Okay, we'll solve one problem, then you will understand. As of now, you just know what is the concept. Okay, right? So till here it is clear. I want to pause. Sir, randomly getting logged out. Randomly not able to join the meeting. Not able to join the meeting is because Um, it's locked. You need to check your internet connectivity, guys. Okay, I'll allow you. Okay, you just check your internet connectivities. There is one raised hand. Who is this? Lakshmi Saujanya. What is the doubt? I'll allow 1 minute. Everyone in the meeting will be able to unmute. Okay, we will hear your voice. Today the class is overly silent. Okay, okay. Now you have been given unmute permissions. Okay, you can interact with me now. Are you understanding? என்ன சத்தத்தையே காணா?
எஸ் சார். எஸ் சார். சம் போடுறப்ப இன்னும் கொஞ்சம் ஈஸியா புரிஞ்சிடும் சார்.
Your voice is so low. 1 minute.
சார் நிறைய பேர் ஆட்டோமேட்டிக்கா மியூட் ஆகுறதுனால எங்களால எதுவும் சொல்ல முடிய மாட்டேங்குது சார்.
நல்லது. இப்போ கேட்க முடியுதுல்ல எல்லாருக்கும் டிஸ்டர்பன்ஸ் இல்லாம. It is important. Okay, right. But I will give you opportunity for you to talk. Okay, don't worry. So this way the class is more secure. I mean to say, everybody will shut and listen. Okay, which is very important, right? And it is good for me also to make sure that the transfer of knowledge is possible. Okay, I'm not blaming everybody, but there are some few people who are doing this. Okay, right? So that's the reason I wanted to update the settings. Okay, uh, and those people also will not learn, and they won't allow others also to learn. Okay, right? So that's the basic thing. Okay, but for it, I love to interact. Okay, don't feel that, oh, sir is not interacting. Okay, but I love to interact with you people. Okay, right? Uh, so did you all understand till here?
So can you just explain the last 2 points which you noted, that we replace the uncertain variables from there? The last 2 points.
Uncertain variables on the Excel sheet.
Yes, the bottom 2 points which you mentioned.
This one, we replace the uncertain variables.
Yeah, that 2 points.
This
Yes.
one, this you will understand when I take the problem. What I mean by this is very simple. I mean to say, see here, we replace the uncertain variables from the simplex table as we increase the number of iterations. அப்படின்னா என்ன? What do you mean by that? What do you mean by that? I'll tell you. When you start doing the problem, simplex table 1, 2, 3, 4, it goes, no? That time, what happens is your S1, S2, S3 will go out. They will leave the table, and it will be replaced by decision variable x1, x2, x3. It will be replaced by the decision variable. Okay, that's the meaning of that. That is what I said here. We replace the uncertain variables as we increase the number of iterations, and at the end, now there's a question. What is the question? When do we stop? எப்போ இதை நிறுத்தணும்? Okay, it's simple. When you have all the Cj minus Zj values as 0 and less than 0, okay, you just cannot keep doing the simplex table. Okay, right? According to my experience, almost about three simplex table, you should be able to get the Cj minus Zj value as 0 and less than 0. Okay, it will not go beyond that. Very rare cases, it will go up to 4. Okay, right? So if you have messed up the problem somewhere, then definitely you're not going to get the answer to that particular question. Okay, right? So be very careful while uh, writing down the values. Okay, while writing down the values of the coefficients. Okay, right? So that is the last point, and sorry, the second last point. And then we take the corresponding values of x and y and substitute the values in the objective functions to get the value of max z. What do you mean by that? In the optimum simplex table, where all the Cj minus Zj values are there, no, the corresponding values of x and y, whatever is the value of x and y, we take that value and put it in the objective function. We substitute it. Now let me say if in the optimal simplex table x is 2.5 and y is 3.5. Okay, I'll give you an example. Okay, I'll give you an example. So let me say uh, max z, sorry, max z equal to 3x plus 4y, for example. Okay, 3x plus 4y. Okay, now here in the optimum simplex table, you have got the value of x as 2.5 and y as uh, 3.5. So what you need to do is max z is equal to, what you have to do is 3 into 2.5, okay, plus 4 into 3.5. So whatever is the answer which you get, that will be your final answer for max z, which means to say you have to substitute the x and y values in the from the optimal simplex table in the objective function. Once you substitute it, that will be your answer. Okay, and rest assured, this is again very important point to note. Okay, this is all out of experience. Okay, you'll not get it in the books. When your problem is max z, okay, when your problem is max z, maximize. I mean, when your problem is when your problem is maximize, the z value, okay, will always be positive. Any problem, any book you take, okay, if the problem is maximization type, your answer to that problem, okay, max z will always be positive. It will never be negative. Okay, and and uh, okay, and and if the problem is minimize, okay, the value of z will always be negative. You understand? Okay, this is very important point. This you should know, because I told you for oh, I didn't tell you people, this is the first class. Okay, I usually tell my students that for operation research you can verify your answer at any point of time, whether it is correct or incorrect. Okay, so at the final answer, you should be very sure whether my problem is correct or incorrect. So if you are getting a maximization problem, you will definitely get a positive value of z. And if the problem is minimize, then the value of z will always be negative. There is no way that the uh, value of z will be positive if it is minimization problem. No, if you get a positive value, it's an indication that you have committed a mistake. I understand. So I hope I answered your question. Okay. Any other doubts? Any other doubts you have? Please tell sir to admit people who are waiting. Okay. Please tell sir to extend the limit. What limit you want me to extend? Please repeat, sir. I mean, what you want me to repeat? You can talk. You have been unmuted. Please tell sir to admit people. Ask them to join. That's all. Okay. What you people have not understood? What you people have not understood? Can we do a sum? It will be more clear. Of course. Wait, have patience. We will do. Many are facing issues to join the call. Narendran, don't worry, man. Worry about yourself. They are late. Don't worry. Can we do a sum? Okay, we'll do it. Okay. Right? Now I've allowed them. That's all. Shall we lock? Okay, let them wait in the lobby. In the meantime, we will clear out the doubts. Okay. Uh, uh, sir, we are request to go to the next step because working on problem it's better. I mean, you want me to solve a problem? Is that what you are asking? Okay. Okay. Fine. So this is simplex method. Okay, this is simplex method. Many people are asking problem. Okay, I will solve the problem. Okay, right, so that you people will understand. Okay, how it works. Okay, I told you I will do a problem. Okay, right. Okay, good. So let's do a problem for the satisfaction of all the people. Okay, okay, guys. Maximize Z. Okay. Uh, uh, give me numbers. Give me numbers. Single digit numbers. Okay. From 1 to 9. Go ahead. Huh? 8, 8x. Okay. Then quickly, guys. If you take so much time to tell me the numbers, then I'm very sorry.
2, sir.
2y. Then equal to 6. Okay, I got 6 also. Then subject to. Give me the numbers.
So 4.
4x. Okay.
3, sir.
7.
Okay. 3y. Okay, less than or equal to. So what I'm going to do is less than equal to 7. Okay, so that is one thing. Another one. Some more. Give me some more numbers.
5, sir.
5. Okay. Okay, 5x plus
12y.
started 1 minute. Now you tell me. 5x plus 3y. Then
5.
you want 5 again? Less than or equal to 5. Okay, no problem. So this will be 4x plus, okay, 3y, okay, then x comma y, okay, greater than or equal to 0, greater than or equal to 0. Okay, now you see here, this is a problem which you have given me. Okay, this is not available in any book. Okay, and we will solve this problem. Good. Okay. So what I'll do is I'll copy this problem somewhere here. Okay, right. Now you see here, the concept is very simple. First, what you do, you quickly see whether it is in the standard format. You see whether this particular problem is in the standard format. So what's the standard format? Objective function should be maximized subject to so and so, and non-negative restriction should be greater than or equal to 0. So did you see that it is maximized? Subject to is less than or equal to and x comma y is greater than or equal to 0, which means to say what? This is a standard problem. This is a standard format. Okay. Now what you need to do? You need to fill all this in the simplex table. You need to fill all this in the simplex table. See, now you have only x and y. So which means to say what? You are going to have only x1 and x2 or x and y. You don't have anything else. So I will modify the table accordingly. Okay, how? I will modify. You see here, the instead of x1, I will put it as x. Instead of x2, I'll put it as y. Okay, I don't have any x3 values here. Okay, so I'm going to delete this. Okay, and I'm not going to have any s3 also. So if there are two decision variables, there will be two slack variables. If there are three decision variable, there will be three slack variables. Are you understanding? Okay, right. Okay, right. So what I'm going to do here is I'm going to delete this. Okay, I'm going to delete this. So x, y, s1 and s2. At the same time, here also s1, s2, s3. There is no s3. I'm going to delete this. Okay, right. The slack variables are set to 0, 0 always. Okay. Always the slack variables are set to 0 and 0 always. Okay, right. So that's how it is. Okay, right? So that is how the slack functions. In the first simplex table, this is also a note. Okay, make a note. What is the note? The note is simple. In the first simplex table, the values of S1 and S2 are always set to 0. Okay, right. And one more note, the slack variables will always be equal to the number of decision making variables. Okay, what do you mean by that? What do you mean by that? If uh, if decision variables are 2, then slack variables are also 2. That is what it says. Okay, guys, you people have to write down. I will not share this Excel sheet. I want people to write. I want people to Pay attention and write. I'm not going to share this. You take a screenshot, you do whatever you want. Okay, but I'm not going to share this. You either write it or you take a screenshot. Are you understanding? Yes? Till here, have you all understood? We'll see the chat box. I am unable to join the meeting. I have allowed, no? Sir, Excel is stuck. Excel is stuck? No, I don't think so. Yeah, it's moving. Yes, sir, understood. Very good. Okay. Right, very good. Okay. Fine. So, what I was trying to say is this. Okay. There are three notes. One, maximize the z value will always be positive. If the problem is minimized, the value of z will always be negative. Okay. Now let's come back. Let's come back to the problem. Okay. Let's come back to the problem. The problem is here. Okay. So what I have to do here is I have to plug all the values of this particular problem. Okay, inside the table. Okay, this is your problem. I have to plug all the values here inside the table. So how do I do that? Very simple. Whatever is the objective function, okay, you have to put those coefficients here. Okay, right? So what is the coefficient of x? It is 8. So I'm going to put 8 here. What is the coefficient of y? It is 2. So I'm going to put 2 here. Okay, I'm going to erase all this because we are doing a completely new problem. Okay, I'm going to erase the entire. Okay, right? So that's how this. So what I'm going to do here is I'm going to plug all the values. Okay, so S1, S2, the value is plugged to 0. So again 0, 0 here. What is the solution? The solution is the value which is after the equal to sign. So the solution here is 6. Okay, right? You don't get any values here. In this particular thing, you don't have any values. Okay, merge and center. Merge and center. Okay. Sorry. Okay, right. So that's how it is. So how do you? Okay, no problem. Is this? Okay, right. So then what you have to do is you have to plug in the other values. What are the other values? The other values is subject to 4x plus 3y less than or equal to 7. Okay. So what's the coefficient of x? X is 4. What's the coefficient of y? 3. Again, here you leave it for the time being. Then you put the value of solution as 7. Okay. Then for the second equation, the value of x is 5. Then the value of y is 3. And the solution value is 5. Okay. What do you put here? What do you put here? What do you put in these 4 columns? The 4 columns. Okay. There you put a note. It says slack variables are always filled with filled with the identity matrix. Okay, either either a 2 cross 2 identity matrix, or 3 cross 3 identity matrix, ID matrix. Okay, what do you mean by that? What do you mean by that? What is identity matrix? 2 cross 2 identity matrix is 1, 0, 0, 1. Are you getting my point? This is a 2 cross 2 identity matrix. What is a 3 cross 3 identity matrix? 1, 0, 0. Okay, 0, 1, sorry, 0, 1, 0. And the third last one is 0, 0, 1. This is a 3 cross 3. So this is 2 cross 2 IDM, identity matrix, and this is a 3 cross 3 IDM. Are you getting my point? Okay. So now you see here in this, you have only 4 boxes. So in the 4 boxes, you have to put only this. So 1, 0, 0, 1. So put it. Go ahead and put it. 1, 0. And you have here 0 and 1. Are you getting my point? So the table is slowly getting filled. The table is slowly getting filled. Okay. The table is slowly getting filled. Okay. Okay. Now, ZJ, this is very careful. Please listen. Please listen. Very important. How do you calculate ZJ? It is very, very important. Listen carefully. CB into X. CB into X. That's how it works. I will put one for you. Okay. 0 into 4. Let me put all this in the center, so it'll be better. 0 into 4 plus 0 into 5. That is how you will get ZJ. Are you understanding? 0 into 4 plus 0 into 5. Whatever is the value, it will come there. I will go to the next box. See very carefully. 0 into 3 plus 0 into 3. That is what you will write here. Okay. So it will be 0 into 3 plus 0 into 3. Are you understanding? Then the next box. 0 into 1 plus 0 into 0. 0 into 1 plus 0 into 0. Now here, the last one. 0 into 0 plus 0 into 1. Be very careful when you're doing ZJ. This is where people commit mistakes. 0 into 0 plus 0 into 1. Are you getting my point? Then the last one. 0 into 7 plus 0 into 5. 0 into 7 plus 0 into 5. Now you see, I want to put one more note. What is that note? I will tell you. In the Note 1. In the first simplex table, the values of Zj will always be 0. Okay. Understand this word very carefully. First simplex table. Only in the first simplex table, it is 0. If you put a 0 for all Zj values in the subsequent simplex table, your marks will become 0. Got it? Right? Only in the first simplex table, the values of Zj will be 0. Why? Because anything multiplied by 0 is 0. Whatever value let it be. When anything is multiplied by 0, it will be 0. But in the second simplex table, S1 or S2 will go out. It will be replaced by X1, X or Y in this problem. So that time you will not get 0. You have to be very careful. I'll show you. Okay. So now I got this. I'll keep this for you so that you'll understand. So randomly what I'll do, I will put one more column there and I'm just putting zeros there. Okay. This is one more step just for you to understand. Okay. Right. Now what he says, Cj minus Zj. How do you do that? Cj is here. Zj is here. You just have to subtract Cj minus Zj. 8 minus 0 is how much? 8. 2 minus 0 is how much? 2. 0 minus 0 is how much? 0. 0 minus 0 is how much? 0. 6 minus 0 is how much? 0. Are you understanding till here? So this is how you got Cj minus Zj. Then what I said, first you have to find out the key column. What is the key column? The highest value in the Cj minus Zj row is the key column. How do you do that? This is the Cj minus Zj row. In this, which is the highest? 8, 2, 0, 0, 0. Which is highest? 8 is highest. So this will be your, I'll insert one more, this one. I'll put here as Kc. So what is this Kc? Kc means key column. Kr means key row. And Ke means key element. Okay. And then OR is called as old row. NR is called as new row. Okay. Old row, new row. Yeah, that's it. Okay. These are the notations which you have to remember. Okay, right? Okay. So let us come back to this. Okay, right. So this is your key column. Then what he says, minimum positive ratio. How do you find out minimum positive ratio? I already gave. The minimum positive ratio is nothing but solution. Sorry. Solution divided by corresponding value in the key column. Solution divided by corresponding value in the key column. How do you find out that? Now I want the minimum positive ratio for these two. Okay, all this will be blank because you have only two equations. Okay, this is blank. This is blank. Okay, this is blank. Right, this is blank on the top. Okay, right. So you have only two equations here. So you'll have only two values. So how do you get that? What is the minimum positive ratio. I'll add one more column here, so you will understand. Okay, Control C, Control V. Okay, right. Now you see here. Yeah, so you can see the problem. Now you see here, minimum positive ratio. How do you get that? Solution. What is the solution? Solution is 7. So it is 7 divided by what is the what he says, minimum positive ratio is solution divided by corresponding value in the key column. So solution is this. Go horizontally till you reach the key column. See, this is the key column. In the key column, which is the value which is corresponding to that solution? It is 4. Write that 4. Close the bracket. That is what I am trying to say here. Now you see here, I will tell you. Once again, minimum positive ratio is nothing but solution divided by corresponding value in the key column. What is the solution? Solution is 7. Then what is the corresponding value in the key column? Very simple. Go straight till you get the key column. In that, what is the value? The value is 4. So you are going to put 4 here. One more time. Once again. How do you do it for this? Very simple. What is the solution? Solution is 5 divided by go till you reach the key column. What is the key column? The key column is here. What is the value corresponding to that key column? It is 5. So 5 divided by 5. Till here, have you understood? I want people to use the chat box, or I'll give you permission. I'll give you permission. Tell me, have you understood? Hello, Mike. Okay. Admit all. Okay.
Yes, sir. Yeah.
No doubt still here.
Yes, sir. Sir, one mistake, sir. 6 minus 0 is 6.
Exactly.
Sir, in your column, in your table, 6 minus 0 is 6. You have mentioned 0.
Oh, yeah. Okay. Somebody has told exactly. Okay. Fine. No problem. Fine. Okay. Thanks a lot for pinpointing that error. Okay. So that's how it is. Okay. So till here you all have understood. Any doubts?
Yes, sir.
Yes, sir.
Okay. Yes, we have understood. Cj minus zj last column is 6. Okay. Okay. Good. Good. Okay. You people are all attentive. How is 8 minus 0? Answer is 8. How possible? Gokul, 8 minus 0 is 8 only, ma.
Sir, if you don't mind this S1 and S2 table, na, sir? S1, S2 table, how you mentioned 1 and 0, not having the clarity, sir.
This is basic maths.
I didn't.
What I mean to say, what do you mean by that is, in your school, you would have studied something called as the identity matrix. Okay. In the identity matrix, what do you mean by this identity matrix? Any matrix which is multiplied with the identity matrix will give you the same result. Okay. Now you may question me, why am I using identity matrix? It's very simple, because I do not know the values of the slack variable. When I do not know the values of the slack variable, I do not want to introduce any other values so that my decision values will change. So that's the reason I'm going to introduce something called as the identity matrix. Are you getting my point? This is all basics. Identity matrix is basic. There's a topic called as matrices and determinants. Okay, in your schooling. So maybe if you have learned it, then you should definitely know what identity matrix is. Okay, right? So that's how it works. Okay, right? So good. You people have understood. Okay, till here you people have understood. 6 minus 0 is 6 only. Okay, right? New messages. What are the new messages? As key column, could you please allow? Okay. Uh, as why do we consider X as key column? Could you please? No. You do not consider X as the key column. You're not paying attention. We do not consider X as the key column or Y as the key column. Okay. See, I've clearly told you here. Key column. What did I mention? The highest value in the Cj minus Zj row is the key column. Now, if you know basic maths, among this 82006, which is the highest? The highest is 8. So I'm going to consider this X. This corresponds to X. So it becomes my key column. If I get highest value here, that will be my key column. You have not paid attention when I was explaining the concept of key column.
Yeah.
Yeah. Hello? Hey, please mute, yeah, Shobna. You do all your conversation outside, not here. Or I'll remove you from the meeting. Amalaya, they'll come and do all the conversation here. Some have joined in between. Can we know the topic and the basis in which you are talking? Please consider. Okay. Just give me a moment, guys. Shall we meet?
Yes, sir.
Shall we meet at 10:45? And one more thing, people. Yeah. One more thing before I leave. Okay. One more thing is people have joined late. Okay. So yesterday I had put a message saying that I'll start the class at 8 o'clock. Okay. But some of you have joined late. You people do not know what's happening, from where I have got that sum. Okay. Right. So when I come back, so after 45 minutes, when I come back, um, I will actually give a quick revision. Okay, 5 minutes I will take. Okay, don't leave the meeting. I'm not ending the meeting. The meeting is going on as it is. Okay, don't leave the meeting. Just leave it as it is. Go have your breakfast and come back. Uh, don't leave the meeting. And quickly, when I come back, I will explain to you how I got that particular values. Okay, and how you have to plug in. Okay, right. Sir, can you please give the link to join group? I mean, I don't have the link, but I'm a part of few groups. Okay. I'm a part of few groups. You can go ahead and join those groups. The HR group, A23 group. There are certain groups which yeah. Thanks a lot for sharing that link. Okay, right. Yeah, I gave my number yesterday. You know, yeah, just put it 10 marks in maybe decision making or game theory or whatever it is. So every session I'll make sure that I cover at least 30 marks. Okay, right? So that is how it is. Okay, notes, don't have to worry about the notes. I'll give you the notes. Okay, right? I have some material. I will share that material on the group. You can share it to as many people as you can. I'm very sorry. Okay, right? I train you in such a way that you people get good marks. Okay, right? So we set a standard, and we expect you people to achieve good marks. Okay, right? It's just not coming here and telling some copying something and uh, just giving some information and going. No. Okay, my classes aren't that way. Okay, right? So yeah, very good. That's the spirit. Okay. So take a break. Okay, we'll come back after 45 minutes. Don't leave the meeting. Okay, we'll continue, and maybe we'll take it up to maybe 12:45. 1:30 works. 1:30 we'll break for lunch. Okay, right? So I will continue. Uh, till 1:30. Okay. After this break, I'll come back, and then there won't be any break. Uh, till 1:30 you have to sit. Okay, then you can break for lunch. Okay, right? So thank you so much. Wonderful teaching you people. Okay, have your breakfast and come back. Bye bye.
Thank you, sir.
Hey, yeah, welcome. Thank you. Before you leave, okay, my friend is waiting. Okay, 1 minute. I'll allow him. Admit all. Okay, and before I leave, I'll put the Excel for you. People who want to refer that, you can refer it. Okay, for your reference. Okay.
Okay, sir.
Thank you so much, sir.
இல்ல சம்மு புரிஞ்சதுன்னா அதை யாருன்னா எக்ஸ்பிளைன் பண்ணிக்கலாம்ப்பா. ஹலோ ஹலோ
ஏதாச்சும் சம் எக்ஸ்பிளைன் பண்ணா நல்லா இருக்கும்.
You don't worry about the sum. I will explain. First, you go eat. Without eating, if you sit, nothing will enter your head. Go eat and come. I will explain it to you. Don't worry.